these two examples, I want to take the derivative of both the square root of x and the cube root of x. So dealing with radicals. Radicals is always something that students struggle with all the time, with just making sure you're converting it to a fraction in the exponent, so x to some power, and then over here x to some power. But being able to convert it is half the battle, and then it's dealing with the fractions is the second half of the battle. So let's do the square root of x first. We want to rewrite this with an exponent. So square root of x, how would we rewrite that as an exponent? That would be x to the 1/2. So it's a square root. So this is 1/2. And while I'm talking about that concept of writing this as x to the 1/2, I'm going to go ahead and rewrite number 10 just while I'm on this topic of rewriting with exponents. So on number 10, we have the cube root of x. So that would be x to the 1/3. If it was the fourth root of x, x to the 1/4. Fifth root, x to the 1/5, and so on. So that radical, square root, cube root, fourth root, whatever that radical is, the denominator is determined by this value. Oh, I just put 3 in that spot. This one was 3, this one was 2. So if it's a square root, it's 1/2, cube root, 1/3, fourth root, 1/4, fifth root, 1/5, and so on. So now let's take the actual derivative portion. So using the power rule, 1/2 times 1 is going to be 1/2 x, and then we want to subtract 1 from the exponent. So subtracting 1, we have 1/2 minus 1, so this is going to be over 2, this becomes 2. 1 minus 2 is a negative 1 over 2. So 1/2 minus 1 is a negative 1/2. This scenario, 1/2 minus 1 and 1/3 minus 1, those are two scenarios that you're going to know pretty quickly. The more you do these problems, it just takes a lot of practice, and you just, plus like just more logic based, like 1/2 minus 1 is going to be negative 1/2, but sometimes it wouldn't hurt to just do them off to the side as I did right here, especially when we get into like 2/3 and stuff like that. It might get a little bit more complicated, a little bit harder to do that mentally. So not a big deal in the world if you have to just do that off to the side like I just did there. Okay, so I subtracted 1, I got negative 1/2. Now how do we rewrite this though? Because I have this 1/2 x to the negative 1/2. So I could rewrite this, let me just show you here. I'm going to put this 2 on the bottom for a second, and I'm going to leave this x to the negative 1/2. So this is like 1x to the negative 1/2 over 2. We have that 1/2. So now, to rewrite this, this is going to come down to the bottom. I only have a 1 on the top. So 2x to the 1/2. Gotta write out my notation here. Not completely finished just yet. This is x to the 1/2, so we could rewrite this as 1 over 2 square root of x. Either answer it's the exact same thing. It just depends on how much you want to simplify it down, but we'd probably just rewrite that square root of x, but it's not like it's incorrect if you left it as x to the 1/2. So that's the derivative of square root of x. So let's take a look now at the derivative of the cube root of x. So I already rewrote this as x to the 1/3. So I'm going to do the same thing. I'm going to use the power rule. Let me change colors here. I don't want too much purple. I'm going to do 1/3 times 1, which is 1/3. X, subtract 1. So this is another scenario as I just talked about with 1/2, where the more you do it, you'll just know it. And plus, you could probably figure this out more mental, but if you need to write it out like I'm doing right now, this is going to become over 3. This is 3. 1 minus 3 is a negative 2 over 3. So this becomes negative 2/3. And then from here, we want to rewrite it. Same thing as I showed you before with this 1/2. This is 1x to the negative 2/3 over 3. So to rewrite that with a positive exponent, I'm going to bring that down. So 1 over 3x to the 2/3. So f prime of x is equal to 1 over 3 cube root of x squared. Or x squared on the inside. Same thing. There it is. So very common problems here. Square root of x, cube root of x, definitely two derivatives that you want to master and just be able to do very quickly, where you don't have to put a whole lot of thought into it, because it's going to get a little bit more challenging from here. So just master those two radicals and you should be fine with those.